Hello and welcome to the series on design patterns. In this episode, we're going to be looking at the factory method pattern. The factory method pattern is one of the creational patterns from the Gang of Four book or the GOF book. The factory method pattern sadly is confused with the factory pattern, which is not actually described in the GOF book, but nonetheless, because of the name similarities, I think people confuse the factory pattern to the factory method pattern. The factory pattern is a much simpler pattern, but it's not defined in the GOF book, while the factory method pattern is a lot more complicated pattern, and unfortunately is completely misunderstood. And people tend to use the factory and factory method interchangeably, even though there is no similarity whatsoever between the two. There is obviously some similarity that they are both creational or both factories, but the similarity ends there. So just to get that out of the way. Now I'm going to explain the definition here. This definition is straight out of the GOF book, but I'm going to kind of interpret it in my way, so I'm hoping to help you understand this statement. It's a very succinct statement, but nonetheless, because it's succinct, is also ends up being a little ambiguous. I'm going to explain that. So define an interface for creating an object. Let's just stop here. Define an interface for creating an object. In this case, interface means a method. Define a method for creating an object. Up to this point, this is just a factory, because that's what a factory is. A factory has nothing but a method to create an object. That's a factory. So it happens to be a method that is a factory. That doesn't make it the factory method, but the kicker or the differentiator is the second part. But let subclasses decide which instance to instantiate. This second part completely differentiates the factory from the factory method factory method pattern. The second sentence here, the factory method lets a class defer instantiation to subclasses. This is nothing but a reinforcement of the second part here. So a factory method lets a class defer instantiation to subclasses is nothing but saying, but let subclasses decide which instance to instantiate. There's a slight subtlety here, which we'll look at in our code, but for the most part, the second sentence is just reinforcing the second part of the first sentence. But if you were to analyze the second part deeper, you realize there are two hierarchies at play. There's one hierarchy that has the factory method defined in it and allows subclasses to instantiate or decide which instance to create. But there's a second hierarchy, which is, what are you instantiating? That the fact that these subclasses are deciding which instance to create is the instance of the second hierarchy. So let's look at a visual representation of that. What we have here is one hierarchy called the member manager base, and then a member manager child 1 and a member manager child 2. That's one hierarchy. The second hierarchy we have is the email service base that has, again, two descendants, the email service class and the email service stub. Two completely different hierarchies. Okay, now let's look at the definition of the factory method again. Define an interface for creating an object. Oops. Define an interface in this class to create an object of this class. Define an interface or a method here that creates an instance of a type email service base, and let subclasses decide what instance to create. So the subclasses have an opportunity to override this method and re-implement this method here, again deciding to either create an instance of this class or some other class in this hierarchy, the second hierarchy. Now the fact that they have like a one-to-one correspondence here is just by chance. It's just for example's sake. There's no reason for them to have a one-to-one correspondence. This hierarchy could be fairly long and this one could be fairly shallow. It's just for an example here. So now let's look at some code implementations of this. Okay, so what we're going to do here is I'm going to create project. This is going to just be a console application, and I'm going to call this application factory method console app, and the solution factory method sample. Okay, so we have our project, and what I'm going to do is now start creating the different hierarchies. We remember we have the two hierarchies we need. One is the member manager base and its descendants, and the other is the email service base and its descendants. So the first one is member manager base and its descendants. So here's the member manager base, and let's also create an email service base. Here's the email service base. Now this email service base is abstract. This is not a requirement by the design, but I'm going to make it abstract. And we have a method in here, oops, that's called send emails, and it's an abstract method here, so there's no implementation. And then we have a descendant class here, so let's call this email service that descends from email service base, and it has some implementation in this case by overriding the send emails method. And its implementation is pretty simple. Of course, this is a console application, so rather than actually send an email, I'm just going to print it out of the console that says let's say emails have been sent. So if this was a real emailing service, when you call send emails, it actually did the job and sent the emails. That's what we're going to imagine this class to do. Now in the member manager, let's also have this member manager abstract. It's not, again, I said a requirement, but just for the sake of this example. Now the member manager makes use of a email service class. So it's got a private member called email service, and in its constructor it assigns this email service to a new email service instance. That's how you typically do it. Remember, I know a lot of people might be jumping and saying, oh, but you should be using dependency injection and stuff like that. We're not talking about dependency injection here. We're just talking about the factory method pattern. So keep your eye on the ball. Factory method pattern. Now this class could have a method here. Let's say do some work, and in the implementation of this method, it's got a bunch of steps. Let's say the first step is validations are done. Second step, let's say second step, it actually uses the email service and does the send emails. And the third step, it says, let's say data has been saved. And finally, it doesn't have to have all these methods, but just for an example, work completed. Okay. So the do some work method in this member manager base class is making use of this email service as one of the sort of steps, one of the sequence of steps to send out emails. Now, so far there's no factory method yet. We have the two hierarchies, but we've not yet used the factory method. Now the factory method says define an interface for creating an object. And this is where we want to use factory methods. Whenever you have a class, in this case member manager base, that aggregates another class or other classes, one or more classes, you would typically create the classes somehow in the constructor or at some other place. Nonetheless, whenever a class A depends on other classes, use the factory method to create the instance, and that's what we're going to do now. So we're going to define an interface or method that creates an object. So in this case, we're going to define this interface that returns an email service base. I'm going to call it make email service. Make is the convention for factory methods. So when a method begins with the word make, you can, if you're doing it right, you realize it's a factory method. So make email service is a factory method. Now we could have the implementation in this class here, but for the sake of this example, I'm again going to leave this method abstract. And the reason is that if you look at the definition here, the second part of the definition, it says the factory method lets a class defer instantiation to subclasses. So in order for the member manager base to defer instantiation to subclasses, I don't want the member manager to actually have an implementation of the factory method. It's not a requirement. It's not a requirement to not have it. But I'm kind of sticking to the definition exactly. In the next example, we won't be doing that, but for now, I'm going to do that. So I'm going to make this method abstract. Okay, but if this method needs to be overridden by descendants in order to allow descendants to decide which instance to create, then we need to make this method protected and virtual, so that protected so it's visible by descendants, and virtual so that the descendants can decide which instance to create. And so this is now a factory method. It's a simple method. It's just a regular method, but it comes into play when it's in hierarchies. So far it just looks like a factory or a method that's a factory, but because of the way it's being used, it becomes the factory method. Okay, so now the other thing I do is when I have a class that for which I have a factory method here, I'll make this class accessible as a property. So I'm going to define a email service base property called email service, and this email service's getter is going to return either the email service private member, and if it's null, that's the null coalescing operator is going to call into the make email service method. I know this looks like a little confusing. Essentially, it's just a simplified version of a property getter, and that says when you access this property, if this email service instance is not null, then return it as it is. If it's null, then initialize it using this method, assign it to the private member, and return it. It's like a lazy loaded property. So over here, we now use the property. So every time you access this reference, if this reference is not initialized, it will be initialized by calling this method automatically the one time. The next time it will reuse the same instance. And this is the basic implementation of the base class. So here's our factory method. The property is just another convenient way of making use of, in this case, an instance of an email service that may have been initialized at least once using the factory method. And this method here is making use of that email service. There could be other classes that are being used by this class, and they'll all follow the same pattern. Now we don't need this, but I'm going to keep it here as a commented out method so we can refer to it in the future. Okay, now we need a descendant of this member manager. So let's have a descendant here. Let me also scroll this up a bit. Let's call this member manager, and it descends from member manager base, and it implements. See, this should be, instead of protected virtual, this should be protected abstract. It doesn't have to be, but again, because we don't want implementation in this base class, it's abstract, thereby forcing descendants to actually implement this method. And this descendant in this case just returns a new instance of an email service. So the base class has defined the interface for creating an object, but it's the descendant that actually overrides the interface and has an implementation, thereby deciding what instance to instantiate. Okay, so far so good. Now let's use these classes to see how this works. So I'm going to flip over to the program CS class here, and in here I'm going to use it. So bar member manager is equal to new member manager, call member manager dot do some work, and then console read line just to halt the execution at this point. Now if you would run this, what you're going to see here is that this emails have been sent method is the one we want to look at. So it did the do some work method, which executed, and these 4 lines were written out of the console. The one we're really interested in is this emails have been sent. So assuming that thousands of emails were sent in this method, you now have confirmation that the emails were sent. And that's great. However, let's say you want to test this class. You want to test the member manager class here. And at the time of testing it, you obviously don't want to be sending out all these emails. So what do? So one of the refactoring sort of katas, if you will, for the factory method, or one of them that uses the factory method, it's called extract factory method and override. So let's look at that. In our base class, we've already extracted the factory method. That is, instead of having something like this, we have extracted a factory method that actually does the work. And in our descendant class, we're going to have another descendant. Let's call this member manager for test. That also descends from member manager base, also implements the factory method or overrides the factory method. And in this case, it essentially returns an email service stub. We don't have a class here, so let's go and define that class. So in this same CS file, for the sake of brevity, I'm going to define an email stub, email service stub, that descends from email service base, right, and implements. And what we have here, instead of sending out email, we say we'll write out no emails were sent. Just so you know that is calling this method. Now the member manager descendant that we have here, probably a typo. Okay. So this member manager for test is essentially overriding the factory method and deciding what instance to instantiate. It decides to instantiate an instance of the email service stub. The original one was instantiating an instance of email service, which is really sending out the emails. So if I wanted to test my member manager, and we know the member manager is dependent on an instance of an email service base, we're not having to go through any contortions in our design. All we're doing is we are descending from the member manager, a one for test, and we are overriding the factory method, or factory methods as the case may be, returning stubs instead. So let's check out how that will work. So again, in our program CS, instead of instantiating an instance of member manager, we create an instance of a member manager for stub for testing. And what we should see here when we run this application is that no emails were sent, because the member manager for test has overridden the factory method, and it is returning an email service stub. So we are still truly testing the member manager, or in this specific case also the member manager base. It's the one that has the real implementations. But the member manager for test is allowing us to test the member manager. It's immediate parent, which is member manager, because it's not changing implementation, it is just changing the instance that is being created. So if there's any implementation in the base class, it's not, this could very easily be just descending from here, it didn't have to be descending from base. So if you had other implementations in this class here, you're not changing it, you're just overriding the factory methods for those classes that you want to decide which instance you want to create. And that's one use of a factory method pattern. Again, there's the two hierarchies at play. There's the member manager, its descendant member manager, member manager base, then its first descendant member manager, and a second descendant member manager for test. Because this is member manager for test, if you're testing this class, then this guy should descend from that class, not the base class. So, but it depends on how you've designed the rest of the system. The concept is the same. Define an interface for creating an object, but let subclasses decide. So by saying let subclasses, meaning it has to be protected, decide what instance to create, meaning it has to be abstract or virtual so that subclasses can override. And what we do here in both the subclasses is we override the factory method, return different instances or different classes here. One returns an email service, the other one returns an email service stub. So this in fact is the factory method. Now let's look at another use of the factory method, and I'm going to give you an example of a sort of a visual use. This other example could be used for use of a factory method. Could be used in the WinForms application, ASP.NET Web Forms applications, or any other place. It's just another way to look at the same pattern so that you're not confined to using the factory method pattern only for testing purposes, because it's an extremely powerful pattern, very, very useful. Unfortunately, as I said right in the beginning, completely misunderstood. So I'm trying to show you another use of the same pattern. Before we get to code again, let's look at the diagrammatic view. So here's the one we saw just now, and the code that we implemented. Let's look at the second. It's obviously the same. But what I want to show you here is there's a form base and a form child 1, form child 2 as one hierarchy. And then these forms use a user control base and a user control 1 or a user control 2 descendant from this hierarchy. So define an interface here that creates an object of type user control base, but let subclasses decide what instance to instantiate, either user control 1 or user control 2. Now, because this is the forms related thing, it's a little more complicated than the simple POCO kinds of classes, but nonetheless I think you'll find it pretty useful. So put your seatbelts on and let's go for the ride. So I'm going to create a new project in here for this in the solution. It's going to be a WinForms application. I'm going to call it's going to be added to the same solution. I'm going to call it factory method. All right, WinForms app. Okay, so new project has been created. Now this the first form here, I'm just going to call it main form. It's not really participating in our factory methods, but it's just the sort of the entry point into our system. So I'm just going to call it main form, and also probably change its title here to main form so you don't get confused. Okay, so this main form is not participating in the actual factory method pattern parts. It's just there as an entry point. We still need to define or create other forms. So I'm going to start off creating our first form, which is form base. And form base, and the second class we're going to define is the user control, which is user control base. Just so you guys can see that, it's user control base, okay, which is a user control, is descending from a user control, not a form. Okay. Now this user control has a visual rendition, so it has a visual representation, and let's see what that looks like. So for the base class itself, we have a label, and this label is just here to indicate that it's part of the base class, and I'm just going to define its text property here. Let me zoom out and define its text property. Let's call it from base user control. Okay, so all we are seeing is there's a label on this form, and it's got a text of from base user control, so we can get a sense of where it came from, because it's all visual at this point. Now we have a descendant user control that descends from this user control base. So I'm going to create a new user control. This time, because I'm inheriting from a visual control, I'm going to click in there, and then I'm going to say inherit user control. And when I create inherit user control, I'm going to give it a name called user control child 1. And in this case, it's going to descend from our user control base. So I'm going to pick that. So that's it. That's how you visually inherit controls. So that's our child 1. Similarly, I'm going to create another child user control that descends from our base. I'm going to go through the same steps. I want to zoom in here. It's the same concept. I'm also going to name it user CTRL child 2. Pick user control base as its parent, and now we have a user control 2 child that descends from user control base. So at this point in time, let me just zoom in here and show you what we have. What we have is our user control base and its children. We have a form base, but we don't have any descendants from this form. So let's go create those as well. Okay, so same thing I'm going to do. I'm going to inherit a form. I'm not going to create a new form from scratch. I'm going to call this form form child 1. It's going to present to me with this dialog. I'm going to pick form base as the parent, and okay, that will create for me form 1 child that descends from form base, and I'll repeat this step again for form 2. Okay, so and there's another way to do this. I'm just going to keep it simpler. Child 2, and I'm just going to manually say it descends from form base. I just find that easier, even though visually it works the same way. So if you look at the forms visually, let's go back to our the base form. Now base form has not defined any methods here. It's got no factory method or nothing defined. So let's do that. What I want to say is that the base class, the base form, uses the user controls, the base user control, and any of its descendants. So let's wire that up. So we call this user control. Now you could just say, new user control base or child 1, child 2 over here. But rather than do that, we know better, right? We're going to kind of refactor right off the bat. So extract factory method and override. So we're going to kind of do that already. So we're going to make this make user control, right? And we implement it here. Now in this case, we don't have to make that, we don't have to keep it abstract. We'll actually have implementation. And what we'll do is we'll just return the user control base, which has got that one label in it. So the base form defines a factory method. This should actually be user control base, and it implements it. But because we want this factory method to be accessible and overridable by descendants, this method needs to be protected, and of course virtual, not abstract in this case, because it does have implementation. Now, one of the nuances of WinForms is that when you have a visual control, you must have a parent to it. This parent has nothing to do with our hierarchy. It's just a Windows thing, or Windows forms, or Windows controls thing. And the parent here is this, which is this form happens to be the parent for that user control. This is not an object oriented hierarchy here. It's just a nuance of WinForms. Okay, so if you were to look at the visual representation of this form, you'd find that, or any of the descendants, you should find that they are already inheriting that user control. So you see the label here, right? What we won't see, of course, is the descendant, because none of them is actually overriding the factory method yet. Let's also, while I'm just going to close out all these windows here so we can have a clean slate. Let's look at our main form. And our main form, I want to put in a button here. What's going on? Okay, this button should create an instance of child 1, which is the child form 1, and the second button should create an instance of child 2. Idea is that when this application starts, when I click on this button, it should create an instance of the form child 1. When I click on this one, it should create an instance of form child 2. That's all this form is being used for, is to create an instance of the other forms that are part of the factory method pattern here. So in the click event of this form, I want to create a new instance of form child 1 and show it. And when I click the second button, I want to create an instance of form child 2. Now, because I've not overridden the factory method in the base class of the forms, so let me open up the base class of the form. The form base class has defined the factory method, but none of the descendant forms, that is form child 1 and form child 2, have overridden this method yet. So we are going to see this base class here. So let's just verify that's the case. Oops, sorry, I need to set the startup project to be this guy. Okay, so here we have, I'm going to click on child 1, and what you see is we have this class, the first child, but the user control is the one that the base form created, because this child class or the descendant has not overridden the base class to decide what instance to create. So let's do that. So in my form child 1, I'm going to override the factory method, and instead of what that implementation is, I'm going to return a new user control child 1, right? And I'll do the same for the form child 2, right? Override the factory method and return user child 2. Okay, so that's all I've done. In both of the descendant forms, I've simply overridden the factory method and decided which instance I want to create. Let's run this application again. So when I click on this button child 1, it creates an instance of, oh, that's not right. Did I miss something? So child 1, return user control child 1, that's right. Form base, form child 1. Yeah, so why did that not work? I probably made a mistake somewhere. Let me see this again. Alright, what we didn't do is we didn't change the visual representation of the user control. So let's do that. So this user control child 1 has not been altered in any way visually. So in the first child user control, we'll put in a checkbox in addition to the label that it's inheriting. We also put another label here that just basically says visually, in this case, that is child 1. Okay, so that's child 1. And for the second user control, the visual representation will contain a comma box instead of a checkbox. So that's our comma box, and it will also have a label, and this label will have the text child 2, so we can see that's child 2. So you got this child 2 user control that has a comma box and a label that says child 2, and the child 1 user control has a checkbox and a label that says child 1. And now if you were to run our application, this is probably just saying save, so I can say yes to that. Okay, so when we run this application now, you'll see that when I click on child 1, it creates a form that has a checkbox that says child 1. When I click on child 2 here, it creates a form that has a comma box and child 2. So this is one way to use the factory method pattern to get different behavior, if you will, by defining a method that creates an instance of an object and allowing descendants, if and when they choose to, override and change their implementation without having to go through any gyrations in terms of in the base class having to put in some hooks in place. The hook's already in place. The factory method is the hook, if you will. That's a visual way of using it. The factory method pattern, once again, is a creational pattern from the Golf book, and it's in my mind a very powerful design pattern, fairly complex because of the two hierarchies. But nonetheless, I hope that in this episode I have been able to explain to you the factory method pattern, how it is not at all connected to the factory pattern, which is it's a useful pattern in itself, but it's not one of the patterns in the Golf book, and it certainly is not something that looks like the factory method pattern in terms of the way it's been implemented. The key differentiator in the factory method pattern is that there are two hierarchies here. As you can see, there's one hierarchy of a set of classes and another hierarchy where this hierarchy uses this hierarchy. This is the key differentiator in the factory method, or the telltale sign, if you will, that tells you that either you can or you are using the factory method pattern in this scenario. So I hope I've done a good job of explaining the factory method pattern to you, and I shall see you guys the next time.